All right, a function consists of a set called the domain, which is all of your inputs, and a set called the range, which is all of your outputs. You can think of a function like a machine. You put something in, you get something out. The function takes the inputs, gives you outputs. Now, the rule for a function is each input can have only one output. Each input can have only one output. If you put one pan filled with cake batter in the oven, you get out only one cake. Unless, of course, that pan was a cupcake pan, and then you get out 12 cakes, and then the analogy kind of breaks down. But you get only one cake. One input gives you one output. If for some reason you've got an input that gives you more than one output, it's not a function anymore. So the first thing we want to learn to do is identify the domain and range. Example 1 gives us an input-output table, and we're often going to have tables from which to identify the qualities of our function. So this table shows us the cost of various amounts of regular unleaded gas from the same pump. Identify the domain and range of the function. Now in this case, they were really nice to tell us what the input and output was. If they hadn't told us that, we would have to use common sense. And common sense would tell us that we pump a certain number of gallons and that determines our price. Okay? So since we're pumping the gallons and that's determining our price, the gallons of gas is our input and the price that it determines is our output. So they give us the various inputs there, and as we defined domain as the set of inputs, what are our inputs? What's our domain? Let me make it a little bit more clear. It's a list of numbers that they give you as the inputs. What's the list of numbers that they give you for inputs? Emily? 10, 12, 13, and 17. That's your domain. 10, 12, 13, and 17. Now, if I want to describe this as a set, the book doesn't quite cover this, but it's an important thing to learn. To identify this as a set of numbers, we put braces around it. That's the weird looking parenthesis thing. And we could put D equals. In other words, our domain equals the set 10, 12, 13, and 17. Those are the only numbers they give you in that table, so that's our only defined domain. We don't say 10 through 17 because we don't have 11, 14, 15, 16, or 11.5 or 12.7. We don't have those numbers. All we have is 10, 12, 13, 17. So that's our domain. Everybody get so far? Okay, super complicated concept. Let's see if we can make the leap from that to the next step. Range is the set of outputs. What's our range? David? 1999, 2399, 2599, 3399. There we go. It's all of those output prices that they give us. It's the outputs that go with the inputs that are in our domain. The outputs that go with the inputs that are in our domain. Everyone good so far? This means yes. This means no. This means I don't know. All right. Another way we might see a function represented is with something called a mapping diagram. Mapping diagrams are pretty handy. Mapping diagrams look like ovals or little boxes that contain all of the numbers. One for the inputs and one for the outputs. In other words, one for domain and one for range. And then it's got arrows that tell you which inputs go to which outputs. And so we would say that the input of 1 maps to an output of 0, because I got an arrow going from 1 to 0. And the input of 2 maps to an output of 1. Now let me ask you a question. If we go back to the qualifications of being a function, it says that each input can have only one output. Is this mapping diagram representing a function? Does it fit that rule? Does each input have only one output? Nod if you think yes. Shake your head if you think no. Does each input have only one output? Who thinks yes? Who thinks no? Oh, we got a lot of no's. Let's see. Let's look at our inputs. Input number 1, how many outputs does it have? 1. Input number 2, how many outputs does it have? 1. Input number 3, how many outputs does it have? 1. Input number 4, how many outputs does it have? 1. Does each input have only one output? Yes. So the part that's tripping us up is this set right here, right? Now we said the rule was each input can have only one output. It's okay for an output to have more than one input. So it's okay for 2 arrows to go into the same number as long as there aren't 2 arrows coming out of the same number. So for instance, if I had an arrow like this, then I'd have a problem, because then the input of 3 would have 2 outputs. Make sense? Okay. So it's important to note the difference. Let's take a look at example 2. It gives us 2 different relations. They call them pairings. More generally, they're called relations. And we want to determine if these relations are functions. Let's look at A. Is A a function? Does each input have only one output? No. Which one is breaking the rule? 0. 0 has 2 outputs. So that is not a function. There's our answer. Not a function. If they ask you to explain, you would say the input of 0 outputs to 2 and 3. Input of 0 outputs to 2 and 3. How about B? Is B a function? Does each input have only one output? With a table, it's pretty easy to check, because if an input was going to have more than one output, you'd have to see an input listed twice on the left. You'd have to have 2 zeros or 2 ones or 2 fours or 2 sixes. And since you don't have that, then it's a function. Everybody okay with that? Okay. Now, we often represent our inputs and outputs with variables. Our input is called the independent variable. And our output is called the dependent variable. And the reason is because your output depends on your input. What comes out depends on what goes in. If you put cake batter in the oven, okay, hopefully it's in a pan first. So you put it in the pan and then you put it in the oven, you're going to get cake out. You don't put cake batter in the oven and get out like a pizza. It doesn't work like that. What comes out depends on what goes in. That's why our output is the dependent variable and the input is the independent variable. So what we're going to do is we're going to use equations to define a function, and we're going to find our domain and range. So example 3 says the domain of the function y equals 2x is 0, 2, 5, 7, and 8. Make a table for the function, then identify the range of the function. So making a table should be a fairly simple exercise. You're going to need some power tools. Joke is different kind of table, like the one you're sitting at. So we make a rectangle, break it up into boxes. Now generally, we put our input on the top and our output on the bottom. I made a table that was too big. Whole lot of food, I guess. So x on top, y on the bottom. So what am I going to put in the top row? What numbers go in the top row? Yes. Those are my inputs. That's my domain. So I need to figure out what my outputs are based on that function. So if I look at this function here, if x is 0, what is y? 0. We do y equals 2 times 0. 2 times 0 is 0. So y is 0. So our first output is 0. If x is 2, what is y? David? 4. We would put in 2 for x, and 2 times 2 is 4. This makes sense to everybody? So if x is 5, Sarah, what's the output? 10. And if x is 7, Lauren, what's the output? 14. And if x is 8, Kyla, what's the output? 16. Okay, so we found the outputs that go with our inputs. So we have made a table for the function. That's the first half of our answer. Then it says to identify the range of the function. So we should be writing range, and we need a set of numbers. What set of numbers are going with our range? Cameron? Yeah, what are they? 0, 4, 10, 14, 16. Those are the outputs I got for my function. So that is my range. Make sense? Make sure you have both parts of your answer when you're doing your homework. Make sure you give both the table and the range. Any questions? Comments? Concerns? Cookies? Okay.